Hello, everyone. I'm Sudeep Charles, and I head product marketing for Chef Desktop. With me today is Chaitra, who leads product management for this product. We'll also be joined by Nishal Reddy from Chef's product management team and Amulya Tomar from the engineering team as well, right? So it'll be a good discussion through the webinar. And over the next hour today, we'll cover an overview of scripting in the context of fleet management. We'll discuss, better approaches to scripting and see how this paradigm can be orchestrated with Chef Desktop and the benefits, of course, that you can derive from this approach, right? So with that said, let's get to it. There are multiple challenges while using scripts and managing fleets, right? So the first one, of course, is brittleness. And what do I mean by that? Well, the time between releases, especially when you're following a continuous deployment principle or a methodology, is rather short, right? And if there's an issue in terms of the automation of the script that occurs, you're not going to be able to determine whether the failure is actually due to the code or because the script failed, right? And all of that typically causes your ability to deliver code, completed code regularly and quickly, right? That itself endangers the entire CD paradigm, right? It makes it very brittle. Inadequately structured scripts also cause problems in terms of just checking in and checking out, right? Or if you want to roll back, changes, you want to test these changes, you want to deploy specific versions, all of that becomes a problem with scripts. Idempotence is another one, right? The quality of the scripts is that in terms of the way they are, is that no matter how many times you run a script, the results will not necessarily be the same, right? You can't really, place bets and say, hey, every time the script runs, it's always going to deliver the same results, right? And that's a challenge, especially with scripting. There are, of course, debugging issues, right? Scripts can be complex, and because there is no standard to maintaining them, debugging becomes a problem, becomes time consuming, and very often things can go wrong, and you won't even know about it till it's very late, right? So system administrators typically spend a lot of time trying to fix these problems, and that makes really their life a lot more difficult, right? So those are the very quickly in terms of just the challenges with scripting overall. KPMG actually conducted a survey of around 50 executives that were familiar with scripting and using scripting for infrastructure automation. And while you can see the results, I'll try and summarize them, right? So 74% of respondents said that the end users were detecting issues even before IT teams were, right? And these issues were essentially because of faulty scripts that weren't behaving the way that they should have. 66% of existing monitoring solutions were simply unable to efficiently detect these anomalies due to bad scripts. So on the one hand, you have end users finding out issues because of bad scripts. You have existing tools that are not able to detect these anomalies in scripts. And then, of course, 55% of respondents basically said that scripting as an approach just cannot scale with more IT complexity, right? As your systems become more complex, your pipeline becomes a little more complex, scripting becomes that much more difficult. Scalability is just not there with scripts. So the best way to possibly deal with all of this is to codify your infrastructure. And what do I mean by that, right? While scripts can be used to automate, endpoint configuration, employing, configuration management systems to describe configurations as code, that can be version controlled by a source code management tool, say such as GitHub. It provides significantly more flexibility, right? And configurations are sent to an automation server in the form of code. Those configurations are then applied to endpoints. And of course, any modifications that you make to your endpoints can be tested. If there's a change that needs to be rolled back, if there are errors that have been caught, you can revert back those changes, right? All of that is possible the minute you start codifying your infrastructure. A much more better option versus just using scripts to kind of manage your endpoints. All this is great, but how does Chef really fit in, right? Chef is a configuration management solution that helps codifying and pushing endpoints and managing endpoints very simple, right? And the way we do it is that the Chef client actually runs on endpoints such as laptops on a regular basis, downloads configurations from a Chef server, and then of course manages those endpoints, in this case laptops, depending on the way you'd like to manage them. And if there's a configuration drift, you're going to be able to fix that as well, right? And one of the ways to do it is to use cookbooks. And cookbooks, of course, are Chef artifacts in which configurations are specified as code. Now, Chef provides resources which are basically code abstractions that may be used to either easily configure your end user machines or other endpoints, right? And these Chef resources are more legible, more versatile than anything that you can do with scripts, right? And Chaitra will deal a little bit more in terms of just legibility and ease of scripting with Chef. And because all of this code is version controlled, all modifications to your cookbook are thoroughly vetted and verified before they're deployed onto an endpoint or a laptop fleet in this case, right? And it can be very easily undone if required as well. Now, what does this do? And I've let you read through it, but essentially shadow IT and the use of anything that is not compliant gets reduced. It leads to satisfied end users because they're not detecting problems because of bad scripts, because you're not using scripts in the first place. There's of course a reduced operating cost because you can easily deploy at scale, manage endpoints at scale without having to throw manpower at it and then go fix and debug scripts at it. It's a lower capex as well, because you're again able to scale with minimal in number of individuals and FTEs actually doing all of this. And of course, there is standardization in terms of the code that you're using to manage your infrastructure and your endpoints, right? All of that becomes standardized. But all of these are benefits, yes. They've also been quantified in terms of the survey that you see, right? So whether it's better collaboration, better configuration of workflows, faster application lifestyle, and a whole bunch of other benefits, these are things that practitioners and executives also attest to, right? So very briefly, that was a little bit about what the challenges with scripting were, what codification of infrastructure could do for you, and what the benefits are. We'll get into the details and how you do it with Chef, right? But before we do, there's a quick poll that will come up. Please do take the time to respond to that, and we'll discuss these poll results towards the end of this webinar, right? With that said, I'll hand it off to Chaitra to take you through the details and show us how this is done. Chaitra, over to you.
Thanks, Sudeep. Yeah. Yeah. So, typically, right, MD and UEMs are used to manage your endpoints. But then there are some workflows, some endpoint management workflows that cannot be easily performed through MDM, because some workflows may be complex, or there may be some workflows which you cannot do through MDM out of the box. And then there are some use cases where you may have to use OS level command line utility and perform some custom configurations. So in such use cases, scripting comes handy. So scripting is, it's a highly efficient tool with limited data structures and variables, and it's very easy to learn. And hence it is a preferred option to get around endpoint management workflows, which cannot be easily configured the MDM UI. And scripting is also used as a tool which can be quickly used to automate your repeatable and mundane tasks. So while scripting did make things better for system admins, it threw light on some of the problems, but it was not without problems, right? So as organizations scale, you see that the number of laptops and desktops also scale. And then there comes a need to automate your repeatable and day-to-day tasks. While scripting could be a possible solution, but it comes with a lot of challenges, right? Because scripts can spiral up in your organization, and they can become really complex and incomprehensible over time. So IT teams get so habituated to using scripts that they don't realize when the scripts spiral up to an all new level of complexity and volume. And it is only as in when you use more and more of scripts that you tend to realize the problems that come with it. And often even the script authors may forget what these scripts are doing, and even if they know, if they are on vacation or if they leave the company, the rest of the team often don't have context on what these scripts are doing, and in case of issues they end up spending a lot of time debugging them. So it becomes very important to extensively document these scripts, or else they lose readability over time. And then there is another problem with scripts, right? So you have to write different scripts for different platforms. So if you want to manage Windows machines, you have to write PowerShell scripts. And then if you have to manage Mac machines, then you have to write Bash scripts or Apple scripts. So even if you have a single unified endpoint management tool, which you're using to manage both Mac and Windows machines, you would still have to maintain different scripts for Windows and different scripts for Mac to manage them. And it becomes very important to validate our scripts before we deploy them onto our endpoints, right? Because an inadequately written script could result in unintended consequences, and it could cause damage to your fleet. And these damages could be like really costly to the organizations, and the whole team would have to spend time finding the issue, finding the root cause, and fixing the issues. And also sometimes we may deploy some scripts, and then we may also think that this is not something we want to do, or there may be changes, there may be mistakes that you do in your scripts, and you deploy them, but you want to roll back changes. So rolling back changes is also something that's really cumbersome with the scripts. And since there is no standard followed to maintain and manage the scripts, it's a challenge, right? So generally scripts are managed either through a shared folder, or scripts are uploaded to the MDM. And there's also this problem with script compatibility with new builds. So there is no guarantee that the scripts that you write today would work with the builds of tomorrow. So with the operating systems and application versions constantly being updated on a day-to-day, not day-to-day, but being updated regularly to avoid security vulnerabilities, there are quite a few times when the scripts that you've written in the past don't work in the latest builds, and the teams have to spend time updating and maintaining the scripts so that all your scripts run seamlessly on your fleet. And finally, there is this problem of running ad hoc scripts through a terminal. So many times IT teams are swamped with multiple tickets from end users, catering to requests, or asking to fix some issues. And IT teams tend to run some scripts or commands through terminal to quickly fix those issues. While quickly running some scripts through terminal would be a great way to fix issues quickly, but then there is no way to track what are these scripts that ran on end user machines. And in case those scripts cause issues later, the IT admin would have forgotten that he actually ran the scripts, and then debugging and actually finding the root cause becomes a big challenge. So typically what happens is IT admins upload some scripts to the MDM, and he would have like different scripts, like he would have Bash scripts and Apple scripts to manage your Mac machines, and then he would have PowerShell scripts to manage Windows machines, and so on. And again, there would be ad hoc requests, and he would be also running some scripts to the terminal to fix those issues quickly. So as you can see, in an enterprise, the number of scripts that run to manage your fleet would only be increasing. So, and then there are more challenges with scripting. So it does not account to configuration drift. So let's just say you deployed a script, but you don't know whether the script was run successfully. And even if it, let's just say it ran successfully and the configuration was changed manually by some, issue happened due to which the configuration got drifted, there is no way to know that. And also there is little visibility into the state of the fleet. And since scripts are not version controlled, it becomes really difficult to debug. Like You don't know the changes that happen to the scripts over a period of time, when the changes happen, what are the changes that happen. So this is something that becomes important to know to debug issues. And there is this other problem of, scripts could also be quite inconsistent at times. So there are times when you run scripts through terminal and it works fine, but then you upload the same script to the MDM and deploy them, it doesn't work. So these are the cases when it becomes difficult to debug scripts as well. And also it is not easy to ensure continuous compliance with scripts. So how can we optimize scripting, right? So if we have a configuration in place which does automated drift corrections, provides code abstractions where you can just pass a few parameters to configure your endpoints, and then you have a SDLC process in place, which would ensure that all changes are peer reviewed and well tested before deployment, and would also provide compliance and remediation capabilities. So Chef is one such tool, and if you use Chef and if you have your Chef clients deployed on all your endpoints, these Chef clients would run periodically on your endpoints, and in case there is a configuration drift that occurs, then in the next Chef client run, it would bring the devices back to the desired state. And then Chef provides code abstractions in the form of resources. We call code abstractions as resources in Chef. And these resources, all you have to do is pass a few parameters, and then all the underlying tasks would be taken care of by Chef. And then you can follow a proper process, and your code could be pushed to source code repositories like GitHub, and changes could be well tested and well reviewed and before you deploy to your production. And Chef also provides compliance and remediation capabilities. Chef provides CIS benchmark profiles, which you can leverage to even perform compliance checks on your fleet. So let's look at an example here. This is a PowerShell script. What we are doing here is we are setting a Windows laptop to a defined power level. And if you compare this to that of Chef recipe, so this Chef recipe has a Windows Power Management resource. And what you can see here is there are a few properties that are passed to this resource, and all the underlying commands and actions that need to happen to actually configure your endpoint would all be taken care of by Chef. So as it's very self-explanatory, right? It's readable, it's elegant, and it's self-documenting. So any person in the team who writes this recipe, he doesn't have to do any documentation, and the rest of the team could just have a look at the recipe, or if a new person joins, he can just look at the recipe and he knows what is happening here. So let's just say you want to perform custom configurations with scripts, right? So if you have an organization and you have multiple departments, say like HR, finance, IT, and dev teams, and you would want different settings, different set of settings for each of these departments, and you would have one script file for each of these departments, where each script file would specify all the configurations that you want to perform for the laptops belonging to that team. But let's just say the dev team has a couple of sub teams, and the sub teams require different versions of the same setting. In that case, you would need to have another set of script to achieve that. And then let's just say there is another setting, and even the sub teams require different versions of another setting. So in that case, you need to add few more set of scripts, right, to achieve this. So this way, as you do more and more custom configurations on a user level or team level, the number of scripts in your IT estate would just keep on increasing. So the volume of scripts increases as and when you do more and more custom configurations and as your IT fleet scales. And in addition to that, we also discussed about generic problems of scripting, right? So combining both of these issues, the problems with scripting only just keeps on compounding. So I want to take you through an example of how you can use a Chef recipe to do custom configurations without having to repeat yourself as much as you do, like you do with scripts. But before we do that, let me take you through a few Chef artifacts. So Chef has an artifact called Cookbook, and Cookbook is where we specify all our configurations, and Cookbook contains a collection of recipes. So what you see here on the screen on the right hand side is a Chef recipe. And so a recipe has Chef abstractions. Chef abstractions are resources, and a recipe can have multiple resources, and each resource would configure a particular setting on your endpoints. So here we have a desktop screensaver resource, and then we have disk encryption, etc. So coming to the example, we have a Chef recipe here, and what this recipe, it has a single resource. And what this recipe does here is it configures screensaver settings to a timeout of 10 minutes on your endpoints. Now, what if you want to use this, not this recipe, what if you want to use a single recipe to perform different configurations for different groups of devices? How would you do that? You could do that with some variables, and these are attribute variables which are defined in the attribute file, which also lies in the Chef cookbook. And here see is we have the default attributes for defined as the dev team, which is the larger team, and then we have team specific configurations for screensaver timeout defined here. We have the sub teams dev team 1 and dev team 2 having different timeout listed here. Similarly, you can also have other configuration specified, team specific configuration specified. And as you see, what we have defined in the attributes file, we have the default attributes here for the larger dev team, but then you want to run configuration for the dev team 1. In that case, you can specify that the team specific attributes in the policy file. So policy file is nothing but a file where you define all the recipes and configurations that you want applied on your endpoints. And when you plan to run configurations for a particular team, could specify the attributes in the policy file, and these attributes would override the default attributes that you define in the attributes file. So we can have a single recipe which could configure the screensaver timeout that you would require for dev team 1, and it would be picking it up from the attributes that you've defined in your attributes file. So with scripts, if you have to do multiple custom configurations, you would end up having a large number of scripts, whereas with Chef, you can do it with a single recipe. And all you need to do is specify some custom attributes like team specific or user specific attributes in your attributes file. And so typically how Chef is used in endpoint management is that, MDM is usually in place, which takes care of the zero touch enrollment and remote wiping, remote locking in case of devices which are lost, or when employee leaves the organization. So and also to deploy your Chef client, right? So Chef client is deployed by MDM onto your laptops, and from then on Chef client takes over and it pulls all the configurations and cookbooks that are uploaded to the Chef server. So let me explain a little more on how the Chef workflow happens. So an IT admin would typically write a Chef cookbook, and he would push it to a source code management repository like GitHub, which would trigger a CI/CD pipeline, and then you could deploy and test all your cookbooks on environments, and then push these cookbooks to the Chef server. So since you have your Chef client deployed on all your laptops, these would pull the configurations that are pushed to the Chef server, and then it would take care of all the drift correction, and it would perform all the automation and stuff. And you could also achieve continuous compliance with Chef's compliance capabilities. And one more thing is you can use a single cookbook to configure your machines of Mac, Windows, and Linux. You have a poll question coming your way. I would request you to provide your responses. Okay, so moving on to the next section. So we have discussed so far on how why scripting was used in the first place in the endpoint management space, and then how there are some challenges with scripting, and how we could optimize scripting. And we also walked you through an example of how you can use a single chef recipe to configure to perform custom configurations on a large fleet of devices. So now the question is, where does Chef fit in the desktop management space, right? Chef Desktop was an offering that was launched early last year, and it uses the same toolchain and processes that is used by the servers to automate configuration management in the server side. And it seemed only logical to use the same toolchain and processes in the endpoint management space as well. And even before this offering was formally launched, we had some of our customers who were using Chef to manage their endpoints, and we have customers who manage hundreds and thousands of devices with a small team of just 2 or 3. And how they are doing it is they are representing their endpoint state as code, and they are able to automate most of the manual processes, and hence they are able to manage with a small team to manage a large number of devices. And then you can also gain control over your IT resources with the visibility layer that comes with Chef Desktop, where you can observe all your fleet of devices. You can combine, you can look at your the state of your Mac, Windows, and Linux devices. And you can also reduce security and compliance risk with by using Chef's CIS benchmark profiles to run compliance checks, or you can even write your own customized profiles to run your compliance checks. And in fact, Chef, the resources that Chef provides are OS agnostic. So let's just say you have a resource to configure a setting, and you can use the same resource to configure a setting either on Mac, Windows, or Linux. So let's just say you want to create a file and you use this resource. All the underlying OS specific tasks are taken care of by Chef. All you need to do is just pass parameters that you would want to be configured to that resource. And like you can achieve automation via code. You can represent your endpoint state as code, and you can automate most of your tasks. And you don't have to write a lot of code because Chef provides curated content in the form of cookbook. And this cookbook has recipes for most of the common endpoint management use cases. And even if you're new to Chef, you could quickly get started with this cookbook and start managing your endpoints on your fleet. Like I said before, it is you can manage a wide range of devices on your fleet. You can manage Windows, Mac OS, and Linux devices. And then it also does automated drift management, right? So anytime there is a configuration drift on your fleet, the Chef client, which is scheduled to run periodically, would take care of it. So the next time Chef client runs, it would pull the cookbook from the Chef server and bring the device back to the desired state. And Chef also provides a layer of visibility. You can look at all the total number of devices on your fleet, and then you can look at the number of laptops which are checked in and the laptops which are not checked in. And you can also look at the check-in history of a device over a period of time. And if there are any errors with the client runs or the configurations that were applied on your devices, you could see that as well. And you can even drill down further on these dashboards to look at individual devices and see what are all the client runs that happen over time. What of those runs were successful, which of those were not successful, and details like that. And there is also a visibility of layer for compliance, where all the compliance tests that were run, you will be able to view the results of it on the dashboard, and even find out why the compliance check failed. Like I said before, Chef provides CIS benchmark profiles, CIS and stick benchmark profiles for different operating systems, and you could leverage them to perform compliance checks. Or you can write your own compliance profiles as per your organization standards, or you can use the CIS benchmark profiles that provided by Chef, and you can modify them to suit your needs. And you can ensure that your fleet remains compliant. And you can also quickly remediate your non-compliant devices with remediation profiles as well. Finally, why manage desktops or laptops with Chef? What does it bring to the plate, right? So with Chef, you can actually do more with less, right? You can manage tens of thousands of laptops with one or two IT admins. And since most of the process is automated, there is very little scope for mistakes and errors, and hence you would end up with less tickets and mistakes. And then Chef provides CIS benchmark profiles and remediation profiles, using which you can also ensure continuous compliance. And all the changes that you do to your cookbook are tracked from the time you create the cookbook, and every change, every configuration change that you do in your cookbook are tracked. You know when these changes are made, who made these changes. So you have all of that information, which makes it very easy to debug in case of issues. And yeah. And finally, Chef is the tool not just to configure your laptops and desktops, but you can also use Chef to write your compliances code and ensure continuous compliance, remediate issues with Chef. So before we go to the Q&A, we have a poll question. I would request you to provide your responses. So you can ask any question. Sudeep, do we have any questions?
We actually do. Right. So the first one asks, can we customize configurations based on the state of a device with Chef?
Yeah, that's a good question. Yes, actually you can customize, just like you can do team level or user level custom configurations. You can do configuration based on the state of your device. I actually let Amulya from the engineering team to talk more about it and give more details on this.
Sure. Thanks, Shekar. So yeah, definitely, and that's one of the major cases when an organization is trying to employ zero trust in their organizations. So you don't trust based on what user, what department. You just you're seeing the state of the device at that moment when the client run is happening. So based on that, you can look at what OS patch is running or what software patch is running. Then you can decide which way to go. And you can have those sort of conditionals in your recipes. And also you can have just an example, you can look at the firewall state, and if it's enabled, you can make a decision based on that. So yeah.
And Amulya, just to take that a little further, right? This can be done across different operating systems, right? Whether it's Windows or
Sure.
Mac OS, yeah. It's still possible either ways.
Yes, it's cross-platform. Yeah.
Great, thank you. The next one is a question around, does Chef have integrations with any testing tools? This is an interesting one. Yeah. Chaitra, do you have a take on this? Or
yeah, so actually Chef has an inbuilt testing tool called Test Kitchen, using which you can spin up VMs for OSs of your choice, and then whatever cookbooks you write, you can run these cookbooks on these VMs, and you can ensure that your cookbooks are working as expected. And then you can also quickly destroy these VMs. And yeah, so this is a great way to test your cookbooks before deploying them onto your endpoints.
Great. So the summary of what you're saying is it's inbuilt within the Chef
Right.
environment, and you can actually test it with Test Kitchen and
Right.
then deploy.
Right.
Got it. Great. The next one, and I'll read it out. Is it possible to push cookbook updates to an infra server without pushing them to a source code repository? And if yes, what happens when such configurations are applied on endpoints? Are any of those actions tracked?
Yeah, so you can do that. You can push your cookbooks to infra server without pushing to a source code repository. And any configurations that are run as part of this, you can still look at all the changes that happen as part of that in the Chef client run, or you can view them on your dashboard. But then it wouldn't give you the audit trail like it would when you use a source code management tool. And we would recommend to follow an SDLC process, because that would give you more fine-grained control over your configurations.
Got it. Got it. And while we are trying, and there are a couple more questions, but do keep your questions coming, and we'll answer them as we see them, right? All right. So next one, Chaitra, is how do you deploy the Chef client onto laptops? This is a very interesting one. What are your thoughts, Chaitra?
Yeah. Like I was repeatedly saying how Chef client brings your devices back to the desired state, right? So you typically what happens is we use MDMs to deploy Chef clients onto your laptops, and from then on a Chef client takes over, and it pulls all the configurations from the Chef server, and it is scheduled. These Chef clients are scheduled to run periodically. So anytime there is a configuration drift, these Chef clients in their next run, they would apply the configurations again and bring the device back to the desired state.
Sure, and of course there is visibility to which parts of your fleet are compliant and which are not, right, across
right.
operating systems.
Right. So in addition to having a visibility layer on the devices that are checked in and the client runs and stuff, there is also a visibility layer for your compliance. You can view all the compliance tests runs on that dashboard, and you can even drill down further to see why a particular compliance run failed. And you can even remediate those issues with your remediation profiles.
Yeah, and do you want to maybe talk a little bit about the fact that we could start remediating right from the dashboard itself? I think we could enable that as well, right?
Yeah.
Awesome. Okay. The next one. How do I need to know Ruby to use Chef?
Yeah. So this is an interesting question. So although Chef is Ruby underneath it, right? We actually have written a Ruby DSL on top of it, and it comes with a lot of abstractions that you can use to start configuring your devices. So you can I think you need to have some basic programming language knowledge. It could be any language, and with some basic Ruby fundamentals, you should be easily get going with Chef.
Yeah, sure. I'll like to add to it. So for our content, at least that we provide in desktop, we have YAML recipes as well. So if Ruby is a problem, then uh, they can any user can get started with the YAML configuration, and that's very easy to do that. Yeah.
Awesome. Do keep those questions coming in. And while we wait for those questions, why don't we bring up the results of the poll? Maybe could we have the results of the first poll, please? Well, do you write scripts for managing end user machines? And well, it's Overwhelmingly, yes. Sometimes, well, this is slightly tricky, but it does look like a majority of people do write scripts at some point in time to manage, their end user machines.
Right.
And it'll be very interesting to hear in terms of what the challenges are. Uh, but I would assume that an approach like this probably makes life a lot easier if you're a sysadmin or an IT ops person, in terms of codifying your infrastructure and then deploying configurations to endpoints, the ability to test those configurations before you roll them out. And should there be a challenge, to be able to roll those changes back easily, I think makes life a lot easier. Sure. So why don't we get the next one up, please? How do you write your scripts? Well, from scratch, or we find them from forums, GitHub, or blogs? That is very interesting. I'm very tempted to ask, maybe Amulya, Chaitra, why don't you weigh in as well? It's the easier way of doing things to get scripts from forums and GitHub. GitHub perhaps much more reliable. Blogs and forums not as much. But do you see downsides to doing this as opposed to using tested cookbooks that will stand up to reliability far more? Amulya, do you want to take that?
Sure. Yeah, and I think Stack Overflow is missing from there. That's one more major source of scripts like that. So yeah, and definitely whatever is out there, it's community generated, and because it's community generated, it's not owned or like there is no responsibility of one person to maintain it. So as by the time somebody uses it, some update has happened, some library is deprecated, something is changed. So that becomes a problem whoever uses that community content. So and especially in for scripts, right? There is no abstraction. Abstraction is missing, so it's very hard to debug when you use such like scripts of these resources. So yeah.
Correct. And I think you also touched an important point, that since there's no way of understanding the chain of control of any of these scripts, there's literally no way to say that they're completely going to be ironclad, especially when it comes down to standing up to compliance audits and those kind of things. Correct?
Exactly. Exactly. It's so deep, like it's so dense, even for like similar minimal configurations that you can't go line by line and make sure that it's working. Only after. So what happens is they have like you have a test machine, you are an IT admin. They'll have a test machine and they'll deploy that there and manually check what was the outcome. If it was not, then yeah, they go back and see. And it's very like tedious process.
Got it. Chaitra, did you have anything to add?
No, I think Amulya has covered it really well.
Great, great. All right, so why don't we bring up the next poll question, please? What challenges are you facing while writing scripts? Need to write for multiple operating systems, difficult to debug and test. And of course, we don't write scripts, which probably is a good thing. But the ability to write scripts that work across or use mechanisms that work across operating systems, Chaitra, do you see them as being really impactful when it comes down to productivity for sysadmins or IT ops individuals, just being able to use a single mechanism across operating systems?
Yeah, it does, right? So you need to have like expertise to write scripts for each of these operating systems, and then again you have to maintain these scripts. So it's a lot of repetitive work, and yeah, it is definitely a challenge. Yeah.
Great. And Nishchal, do you have anything to add to that? I mean, uh, in terms of just the ability to write agnostic scripts or to do away with them at all?
Yeah, I think that's a very valid problem when it comes to managing multiple operating systems, and more so if you're doing it on scale, right? So if you have a lot of machines in your fleet, then you would there will be certain scenarios that can't be done using MDM and through GUI or out of the box features that these tools provide, right? That's when you resort to writing scripts. And when you have to do it, and if you have to do it for multiple operating system, then the work at hand just you know it will just increase by a lot, right? And then you have to manage these different scripts. You have to do it differently for different operating systems, and then you need to have the expertise and knowledge to be able to do that, right? And I think this is when people resort to using something off the bat, which for most time should be good. Maybe I won't paint as pessimistic picture as Amulya did. Maybe for the most part it should be fine, but you never know, right? You never know with all the things that are happening. I would be a little cautious taking something off the bat from forums, but yeah, I think writing scripts for multiple OS is something that is indeed a huge pain point and problem that I've been hearing from multiple sources and customers. So yeah.
Sure. Great. I do not see any more questions. Please keep them coming though, and we'll try and answer them. We'll reach out to you personally and answer them if you do. But with that said, thank you everyone on the panel for your time, and those that attended today. We appreciate your presence and thank you for participating. With that said, I'll hand it back to Raisa.
Thank you, Sudeep. Thanks, Chaitra, Amolya, and Nishil. I'm sure it was a great session for everyone who has attended the webinar today. If you guys liked what you saw, we encourage you to share this presentation with your teammates and professional network. We will share the on-demand version with you in next couple of days as soon as it's ready. So you should be able to access it using the same audience link that you're using now. So with that, thank you again and have a great day, everyone. Bye all.